two additional concepts that are really important in the idea of measurements in general, and in analytical chemistry in particular, are the ideas of accuracy and precision. So we need to define these, what they mean scientifically, their scientific definitions, because these are words that we use in everyday life as well. And that's often the case with many scientific words. They have very specific meanings in science, like the word work, for example, has a very specific definition in physics. But the word that we use in everyday language is not the same, right? It doesn't have quite as precise a meaning. So, accuracy and precision. What does accuracy mean? So, accuracy is how close is the result to the true value. And I'll put true in quotes because, you can always go into, well, how do you know what is true, right? How do you know what value is correct? And the only answer is you have to do measurements over and over and show that you get the same thing over and over again, which is related to the next thing. All right, so accuracy, how close is a result to the true value? Do we have a known standard we can compare it against, and do we know that we're getting the actual, so if, say, we're measuring the concentration of iron in a water sample, is it the actual concentration of iron that we're looking for? Maybe the sample has a known concentration of 10.5 parts per billion. Does our answer give us that 10.5 parts per billion? So that's accuracy. Precision is different. Precision is how reproducible is the result. So if we do this measurement 10 times, will we get the exact same value every time, or is there some scatter due to error in the number of in the results that we get? And so precision is something we're going to be measuring quite a bit. Just as a preview, this is related to the idea of a standard deviation. We'll get to this in the next chapter, I believe. Whereas accuracy, there's not really a statistical way we can analyze accuracy without knowing something about our sample, without having a true value to compare things to. Okay, so one analogy that's used a lot to compare accuracy and precision, and one that I find very useful, and I learned as a student, and I'll share it with you guys too, is thinking about, we're playing darts. So this is a figure from one of the problems in your textbook. So we have 4 different scientists here who are throwing darts at a dartboard. We have Cheryl, Cynthia, Carmen, and Chastity. And I'd like you to pause the video and think about the accuracy and the precision of these 4 dartboard throwers. So of course, remember in darts, we want to get it as close to the center as possible. And so that's our goal. That would be the true value. Right? And so which of these throwers is precise? Which of these is accurate? And I'd like you to pause the video and think about that. Okay, so hopefully you did pause and think. So let's look at Cheryl first. Cheryl, I would say, is neither accurate nor precise. Right? The darts are not making it to the center of the dartboard, with one exception. And they're all over the place, right? She's not very consistent in throwing the darts and getting it where she wants it to go. Cynthia is accurate. The darts are mostly making it towards the center, but not precise. All the darts are not making it to the exact same spot. They're sort of spread out a little bit still. Carmen is what we're going for. Carmen is both accurate and precise. And this is this is our ideal in any measurement, is that we get something that gives us the same thing over and over and is as close as possible to the true value. So, Carmen's throwing bullseyes every single time. That's what we want. And Chastity is not accurate. Her darts are not making it to the middle of the board, but she is very precise. So all of her darts end up in the same spot. It's just not the spot that we want it to be.